In this topic of discussion, we can see some of the intensity transformation problems and histogram based problems. So first let us see about what is meant by histogram. Let S be a set and define hash S to be cardinality of this set. That is, hash S is the number of elements of S. The histogram HA of L, where L varies from 0 to 255 of the image, A is defined as HA of L is equal to hash I comma j, provided that A of I comma j is equal to L, I equal to 0 to n minus 1, j is equal to 0 to m minus 1. Note that summation L is equal to 0 to 55, HA of L is equal to number of pixels in A. For example, consider a image segment. Here there are 16 elements given. So we can take n is equal to 16. Generally, histogram of an image provides a global description of the appearance of an image. Information obtained from histogram is very large in quality. Histogram of an image represents the relative frequency of occurrence of various gray levels in an image. Let us assume this image segment. Here in this table we have represented all the intensity gray level values, occurrence of intensity value, that is number of pixels, and its corresponding probability. So probability of R is equal to nk by n. It means that probability is equal to number of pixels by total number of pixels. For example, 3 has occurred 3 times. 1 has occurred. Similarly, 6 has occurred 3 times. And 5 has occurred 2 times. The gray level 1 has occurred 2 times. And their corresponding probability is achieved by occurrence of the intensity value divided by total number, that is n is equal to 16. So 2 by 16 is equal to 0.125. Here some of the images, its corresponding histogram values are shown. For a dark image, the values are towards nearly to 0. Similarly, for bright image, the values are most probably near to the half of the gray level from 125 to 225. 255 it has been occurred. Same way for low contrast image, it approximately it is vary from some 100 to 125. And for high contrast image, it's equally varied from 0 to 255. This is an histogram of a low contrast image and its transformation. Histogram of min-max linear contrast stretched image are shown here. Its corresponding no stretch, linear stretch, and their values range are given here. For an image with black and white image, how the histogram is varying. It is simply 0 for number of pixels and black for some number of pixels. So that is shown here. For an image kind of this square type image with two opposite side, that is a black color is varying from 150 to 250 for a particular value. So for this also the histogram is same. Now for an image, the like Lena image, say A, its histogram is varying equally from approximately some 25 to 255. So image histograms are shown and its histogram equalization is also shown. So we can see the difference here. The result of image histogram equalization is performed uniformly for all the types of dark image, bright image, low contrast and high contrast. And its corresponding histogram after that is being same, almost same. Then what is meant by histogram specification? The histogram equalization method can generally only one result of an approximation to uniform histogram. Hence, histogram equalization method is not suitable for interactive image enhancement. It will be better if we can specify a particular shape capable of highlighting certain gray level ranges in an image. When automatic enhancement is desired, the histogram equalization method is useful. The results are predictable and it is very easy to implement. For some applications, we require a specific histogram. This is called histogram matching. We take an example, a 3-bit image of size 64 cross 64 pixels, the gray level distribution shown in the table, and the specified histogram is also given. Now we have to perform histogram specification on the image and draw its normalized histogram, specify transformation function and the histogram of the output image. Step 1. First we have to calculate the size of the image. It is m into n 4096. We compute the normalized histogram. It is given as 4096 is calculated where the size is given multiplied, length and breadth is multiplied, is equal to 4096. And we compute the normalized histogram. Here all the pixel values and its corresponding nk is listed, and how we calculate the probability as we explained in the earlier slide. Number of intensity values divided by total number of pixels. Then normalized histogram is being redrawn, and it is then we find the histogram equalized values using the formula S is equal to, that is transformation of R. S is equal to image transformation of R, L minus 1 summation probability of R. So using this formula, if we calculate for all the values from S0 to S7, the values are listed as it is. Then we have to round the values S to the nearest integer. So 1.33 is shifted to 1. Similarly, 5.67 is rounded to 6 and 6.86 is rounded off to 7. So like that, 3.08 is rounded to 3. So similarly, we have calculated the S values. Step 2, we compute the values of the transformation G. So here, it is shown here how it is calculated. The values is shown here. 7 into 0.19, we got 1.33. 7 into 1.19 plus 7 into 0.25 is 308. So next step, we have to calculate the capital G. Same way as we did in the earlier step, we are using those values, rounded values, and then we are calculating it. Then we know that from the data given, P of 3 is equal to 0.15, 4.20, 5.25, 6.30, 7.35. Using those values, the transformation function obtained from the specified histogram is drawn. Then next step, we find the corresponding value of ZQ so that the value of G of ZQ is the closest to SK. So for each value of in the table, in the graph where we are obtaining that values for 1 is 3. For 3, it is equal to 4. So like that we are arranging the values and listing in the table. Now mu nk is being calculated. Based on that you refill the table now. New nk. Similarly, using the new nk, how we calculate the probability. Those values are now the calculated values for histogram. The histogram of the output image can be redrawn is as shown. So this process entirely is called histogram specification and equalization. Calculate and the final result will be shown. Next example we can see on the perform the histogram specification using the original image and the desired image. Unlike the earlier example, here the image pixel values are given for the desired image. In earlier example we saw the probability to be given. Here we have to calculate using the graph they have given the values. Here they have given us a table. Here we have to calculate the histogram equalization for the input image and the target image. Procedure is same. So here as in the earlier example we saw number of pixels are listed here and its probability is being calculated, and cumulative probability is calculated by adding the first two values 0.29, 0.13 plus 0.16 is 0.29. Then cumulatively you add all the three values 0.45. Similarly, you add all the 5 values 0.48. Like that we have to find the cumulative probability. Then L minus 1, that is 8 minus 1, that is into CDF. Then its corresponding H value. So same way here we have to calculate the for the target image. For that we have to calculate the same way. Then grayscale, H, S and the mapping value are listed. Then modified image is shown as in the graph. Given histogram A and B, modify the histogram A as given by histogram B. So like the previous example, we have to calculate the histogram. So how we are calculating is, for the first one, we are calculating the graph, how it is listed, just the graph is shown with the number of pixel values. And now calculate the first table. First we will be writing all the values as n value, number of values, probability density function we are writing, then cumulative probability, then sk into 7. So we are that is L minus 1. L is 8. So 7 is multiplied with the SK value, and then rounding off the next step. Then where we get the 6 is 656 plus 329. Both are getting the rounded value as 6. So we are mapping it to 985. Same way 7 is been obtained for the three values of n, 245, 122, 81. So those has been added and considered as 448. So in the bottom of the example, we have shown how the PDF is calculated. 790 by 4096 is 0.19. Same way, how we have calculated the CDF value. 0.19 plus 0.25 is 0.44. Similarly, 0.19 plus 0.25 plus 0.21 is shown as 0.65. Then how SK is calculated? Multiplying 0.19 into 7. That is CDF into n minus 1. That is we have shown in the previous example. Now equalize the histogram B, that is target one. Same way you calculate all the n values, PDF, CDF and SK into 7, round off those values. Then we get the two tabulations. First and last column of histogram B, then last two columns of histogram A is being taken, and now you check the values how we map the histograph mapping. For the gray level 3, 1 is being mapped. So for 1, what is the new NK? 790. So that is considered. Then for gray level 4, round off to 3, that is being taken. Then 1023. So that is new NK. Now for value of 5, round off to 5, 850 is taken. So like this we are making the values and then reconsidering for the 6, 985, for 7, 448. For 4, 1023, the old value is taken. For 3, we take the 790. So like this we are taking and reconsidering the new table value. So histogram of an input image and its corresponding specified histogram, and the histogram of the output image has been shown as a separate graph. Thank you for watching.